Hi, this is Cyprian from FU for All, and in this first tutorial for Salome Meca 2017, I'll do a very simple example. The purpose is just to show you how the interface works and how you can use some of the functions to create simple analysis. I just opened Salome Meca in Ubuntu 16. So if you don't have Ubuntu or you didn't install Salome Meca 2017, you'll have to go back to the previous video that I did about how to install it on your computer. So, and even if you're Windows, you can install Ubuntu using VirtualBox like I did, and you can still run Salome Meca. So let's open a new project first, new document here. And I'll show you from the start how to create a plate in 3D and how to simply constrain it and how to apply a load and get the results. So it looks very simple, but actually it's much more complex than in a commercial package. So you see here that in this interface you have a lot of different modules. So it works like that. You have first to go into the geometry module to create your geometry model or to import one, and then using mesh module you will mesh it. Then you go in as the study model to create a different definition of the study you will do, so assign the boundary condition, the materials, and the type of analysis you will do. Then run the analysis, and then you will go in Paravis to get the results and display them. So let's go in the geometry module. Now you see that in this geometry module, as soon as you select this option, you get a lot of different small icons here, which represent the features that you can use to build your model inside the software. So some of the features, so you can click on those icons, or you can simply go in the menus here, and you will have more or less the same functions than here. So if you don't, you think it's not easy to find those functions here, you can look in the menus. You can also move back those functions and reorder the menus as you want. So maybe in your interface it will not be exactly in the same order, but that's okay. And here on the left you have a tree in which you will see the geometry and the mesh objects appear. So as soon as I created the geometry, the tree will be populated with the objects that I created. So let's start and create my geometry. So I'll use this box tool, and I will simply do like that. I will put it, yeah, so you see it automatically give you a previsualization of what you will get, and when you change the parameters here, it changes automatically. So I like that. This is good. Apply. Okay, and now I got my my geometry. So now I'll first show you what it would do if you directly mesh that, and then I'll come back to the geometry module to show you how you can improve this kind of mesh. So during this tutorial I'll do, I think, a few mistakes on purpose to show you some of the things that you will probably do, and then how to correct this kind of things. So you will see that it will be good to study this kind of approach. So here I'm going directly in the mesh module, and you see that basically I have nothing. The box has been hidden, so I can activate it again. And here in the mesh modules, all the options to mesh appeared. So I don't have the geometry option, I have the mesh options. And the first thing I'll do is I'll click here, create mesh. And I can create a mesh set. So you have 2D, 3D, 1D, and here I have a 3D body, so I use 3D. And I'll choose hexahedron, and here I have to give it some hypothesis. So hypothesis generally is like the sizing of the elements this kind of thing. So I will use automatic hexahedralization. Click here and choose 15 elements. Well, okay. And just apply and close. And now that you see that I got here a new set, which is the mesh set, with I got a mesh here, which represents the mesh of my geometry in my box, and I get a set of hypotheses and algorithms that are used. So algorithms are the type of measures that I used, and here hypotheses are the number of division of the segments, all that. And here, for each mesh that I created, I have those hypotheses are assigned to this element. So for example, if you have several mesh sets with different hypotheses, here inside you have all the hypotheses from all the mesh sets, and here you have for each model which one is assigned to which. So now that I created that, let's try just to mesh it to see what I get. So let's try to compute that. So here I have resume, and let's look. So it meshed it, and that's good. And here it's white, so it's a bit strange. So let's look closer. Aha! And we see that there is a small problem here, as that basically I give the measure the hypothesis that I wanted 15 elements, so it took 15 elements here, here, and also in this direction. The problem is that here I don't want 15 elements in the thickness. I want only 3, for example. So how would I do that? Well, that's when I have to go back to my geometry and show you how to do this. So let's go back to the geometry module, and I will extract one of the edge inside a group. So let's click on the box and let's go into new entity and let's create a group. And a group basically is some kind of subset of my model. So if I have a 3D model like this one, I can create groups of faces, groups of edges, group of points. Well, and then I can use those groups later on either for meshing or for applying loads. So I need to create the right groups right away, you know, when you start the analysis, so it will be easier. I won't have to come back. But here, you know, I did that so you understand why I'm doing this. So here, let's select the edge here, and the group name, well, let's call it edge, right? Edge. Main shape is box 1, okay, and let's select the edge here, the small edge that I want here 3 elements. So let's select this edge, add it here, so you have to add it here, apply and close, and you see that now under the box you have an edge that appeared. So this edge is some kind of subset of my box model. Now let's come back to the mesh model, and here in mesh, if you click here, right click, you have a possibility to create a sub mesh. So let's try to create a sub mesh using that edge, and here I'll use 1D, and okay, mesh, and here I want sub mesh, mesh. So mesh here, so the sub mesh belongs to a mesh, and the mesh that I created previously is the mesh one. And now I have to select the geometry. So the geometry is this edge here that I just created. I want to create 1D mesh for that, and use wire discretization. Okay, so which means that it will basically mesh it as a wire. And let's see the hypothesis. So here I have different kind of hypothesis. Propagation of 1D on opposite edges. So basically I want all the opposite edges to have the same hypothesis. And so here I will add a number of segments. So you see that here number of segments 2 has been added, and this will be only 3 segments. Apply and close, and you see that this submesh appeared under the mesh. Now what happens if I compute everything again? Aha! Now you see that my model is like I wanted it to be. So basically what happened is that the mesher first meshed my submesh, and then it used this submesh to mesh to take it in account when meshing my 3D mesh set. So it didn't apply the hypothesis of the 3D mesh set, but it applied the hypothesis of 3 elements in 3 segments of the thickness of the submesh, and then it meshed everything, and now I have a better model. Okay, so now let's say that what do I want to make with this plate? Well, let's say that I want to do really the most simple thing that I can do here to show you how it works. So I will constrain it on this face here, and I will apply force on this opposite face. So to do that, as I told you, I have to create 2 faces, basically 2 faces of elements. So I have first to create geometry for the faces, and then create a subgroup of mesh for those elements. So when I run the solver, it knows that I apply the constraint or apply the load to the sub-elements of this face. So let's go back in geometry. So as always, there are always several ways to do things. So maybe if you have another way to do it, you can let me know as well in the comments, and maybe I will learn something as well. So okay, now I got my box, and let's create 2 faces here and on the other side. So new entity, group, create a group, create a face. Okay, I select that, and here I will call it, name here, I will call it BC face, basically. Add it here, apply, and then let's rotate the model like that. Select this face here and call it load face. And add, apply and close. So now I have BC face and load face. Let's come back in the mesh model. Okay, and now I want to create groups of elements. So there's similar way to do that in mesh, create group, and this time it's not group of geometry, it's group of elements. And I want face elements. I have to select my mesh set, so this is the mesh set 1. If, yep, okay. And let's call it, say, BC face. And now you have several types to select the group. Let's group on geometry, so it will use the geometry to, so you can use direct select. Okay, geometry, apply, and you see that here we grouped it under groups of faces BC face, so that's what I want. Now let's create another one, my mesh, so it's this one. Okay. Mesh, okay, face, let's call it load face, group and geometry, and here let's select load face again. Sometimes it doesn't work, I don't know why. Okay, sometimes I have some difficulties to make it work. So if it doesn't work, I can use that find geometry by mesh selection, face, and here let's go on the model, and here select one element that belong to the face. Okay, apply and close, and you see that the load face has been selected. I don't know why it doesn't select it otherwise. Okay, group of faces. Now I have two faces, BC face, load face, so I'm ready to apply those constraints. So now that my model, my finite element model is ready, well, more or less, I have to go to Aster Study, where I will show you how to create your analysis case. So here you see on the left you have case view, and you have several other places. So I'll show you after that why and how to use those other onglets. So the first thing you have to do is to add a stage. So basically each stage corresponds to one thing you have to do when you do analysis in finite element. The first step you see is to define your mesh. So you have small onglets like that go down with different functions, and basically you have to apply them more or less in this way. So first you have to create a mesh. So read a mesh. So you already have your mesh, right? Because you just created from your model. So click on read your mesh, and you see that here a comment appears. So this comment will let you select the mesh you just created. So you can tell it the format, which is med format, and just click on OK. Now, just to explain you those functions, so you have different options here. So if you want to have, let's say, English description of the features, you can let it click like that, and you see it will be mesh check or something. If you uncheck it, the names will be more not understandable like that, but they correspond to the kind of functions that you see directly in the text file. So if you click here, it's more understandable. Now, if you don't, you probably won't use all of the options on those windows. So if you don't want to use those options, you can hide the options that are not used. And doing like that, you will only display the useful ones. So now click on OK, and you see that in my case view here, in my information, I have the mesh which is defined. So this is the first step in my stage. And basically what it does when I define that is that it writes functions like this one inside the text file. So this corresponds to what basically you did. So you just lire maillage in French means read mesh. So it basically defines your mesh. Second step, model definition. So you have to assign a finite element model. So let's go here, and here click here to only one time, and let's select all the elements, and here I have to choose what kind of analysis I want to do. Do I want to do mechanic, thermic, or acoustic? So I'll do mechanic, and here what type of analysis is it? So is it a 2D, 3D, or you see there are a lot of different types of analysis you can do. So in my case, it's a simple 3D analysis. So I click here, okay, okay, and I define my model. Now let's go to the next step, material. So for material, there are two things to do. First, define a material, and second, assign this material to my model. So let's go in the define material. Now the thing is, in basically all the commercial software, you will have a material database with already some data of your material. Here you don't have that, so you have to know the parameters of your data. So here I'm doing linear isotropic. I click here, and basically for linear isotropic analysis, you'll need two parameters: the Young's modulus and the Poisson's ratio. So I have to know those parameters. Sorry, 0.3. Okay. And if you use the gravity, you'll have to add the raw parameter, the density of the material. Otherwise, you'll get an error. Okay, click here, and my material is defined and appears in the walkthrough. Next step, let's assign this material to my model. So let's check the model I have, and let's assign the material that I just created, steel. Okay, that's it. Okay, I forgot to click here because this is a model with only one part, right? So I can check everywhere, but in another real analysis you'll have different materials for different areas, so you have to choose which one. So here it's written exactly one, so it means that you have to choose between one of those options. So you can either select a group of elements or select all the model. So when I do that, so if you don't have error message, it means it's okay. Well, probably. And here you see what you just did. So you define a field mat, and this is the name of the function, and then you have the material steel that you just defined assigned to all the model. Now, time to assign some boundary condition and some loads. So go into assign mechanical loads. And let's block a face. So blocking a face, you have to use that face impo, so which means imposition of some kind of constraint to a face. So this is the function you have to use. Edit, and here you have to choose the group of elements which you have to which you want to assign this constraint. That's where the two element groups that I created previously comes handy. So I have to choose the BC face, and you see here, you see it appear here. Okay. And this is basically constraint, so I'll impose a displacement of 0 on the 3 degrees of freedom x, y, and z. Okay, and I'll change the name. I'll call it BC. And let's see. Okay, the model is defined, so I think it's okay. Okay, so now I have my BC. Now let's assign the load. So let's go into the same assign mechanical load. And let's assign, I want to assign a force, so let's see if I have force. Okay, I have various type of force face, so I suppose it's this one. Edit, choose the group of elements, so this time I choose this one. And my force will be, let's say, 2000 Newton in the y direction. So I have to tell you that I'm putting this value a bit randomly, so maybe this will be too much, I don't know, but that's just for the demonstration purpose. We'll see afterwards. Okay, so my force and my model is not defined, so I go down. Oh, okay. Okay, model is defined. It's okay. Now, what do I have to do? I have to define an analysis. So the next step is to choose the type of analysis you want to perform. So here we are in linear static, so static mechanical analysis. And okay, so it's called ResLin, this is the name, you can change it as you want. I think it means results linear. And then I have to choose material, the material I'm using, so the one I defined, the field mat, and the model here, and then I have to assign the loads, so my BC, and my load. Okay, so now the next thing is to tell it what do you want to output and where you will put the results, where you will save the results that are computed. So for that, you have to click, there is a small button here and you'll see there is more options. Fracture and fatigue and output. So this is what we're looking for, output. And let's click on set output results. And here I have to define the result file location. So basically now I don't have any result file, so I have to click here and create one. So give it a name, that I will call it like that, plate. Okay, and save it. And be sure that it has been associated here. You can tell it the format. And results. Okay, and here you have to choose once again your analysis. Oh, I think I clicked 2 times. Yeah, I have to delete this one. Okay. Okay, so now I think my model is ready for the analysis. So we'll see if I got the result. So what do I do to solve this model? Well, you have to go into different view. You have case view and you have history view. So click on history view, and here you have basically the place where you run your model. So click on the stage and click on run. You should save the study. Okay, I forgot to save my model, so let's save it. So let's call it plate 2. Let's run it. So it tells you the memory it used, and you have, so you can choose different options. So here I'm just using the basic options. And okay, my calculation finished. So if you have problems or if you have errors, you can go here and read the log or read the message, and you will have generally it will tell you at which step it stopped to calculate, so you know the kind of problem you did. So maybe you forgot one coefficient, you forgot to define something. In the previous analysis I was doing, I was trying to do with gravity, and I forgot to assign the material coefficient for the density of the material. So in this log file it just told me we cannot find the row, and then I understood that, you know, I did this mistake. So now it worked, so that's great. So let's go back to case view, and here you have another onglet called data file. So in this data file you have basically two types of data. You have the mesh and you have the results file. So this results file, you have to open it in Paravis. So you right click, open in Paravis, and then we'll have to wait a bit that it starts the Paravis module in which you'll be able to display your results. Okay, so now it opened my model, and for the moment I don't see the result, so I have to select the type of results. Okay, I selected that, and now I see the displacements on my model. So you have different types of visualization. I like this one with the edges. And that's it. So we succeeded to do our first analysis. So what I recommend you is to try to play with those different functions. Try to do again this analysis, make a model a bit more complex to see what you get. Try some other new functions that I didn't describe right now and see what you get. And if you get a problem or something, well, you can put a comment on the video or in on the blog, and I'll see if I'll be able to answer this in the next tutorial. So thank you very much for watching. I hope you enjoyed this video, and again, thank you so much for reading always my blog and supporting what I do about finite element analysis. Thank you very much. So if you're on YouTube, you'll probably find the link to the article and the next videos inside the description. Otherwise, you can go on my blog feaforall.com and click in the category open source FEA, and you'll find all the articles I wrote about open source FEA and the previous videos inside this category. So thank you for watching. I hope that you learned a lot and that you will learn a lot using all the videos that I am sharing on my blog. So if you like those videos, please help me to share them with your friends and other engineers. And also, please let me know what you think in the comments. It's always great to have some kind of feedback. And if you have some ideas of things you would like to learn or do with FEA, please also let me know. Thank you for watching again.